My name is Levi Jones, and this is a video demo for my ray tracer, a 3D engine that's written in C++. So the goal of the ray tracer is to output a 3D rendered image. We start with, here, a couple shapes. We have 3 spheres and the ground. Then we call the cam.render function. What the render function does is we loop through every pixel in the image. And for each pixel, we shoot a ray into the scene and determine what objects that ray is intersecting with. That determines the color of the pixel. In our case, we have anti-aliasing, which means that for each pixel, we shoot multiple rays that have slight random offsets in their direction. That way we can sample the color from multiple locations, and then we average that together to make the pixel color, which makes the image appear smoother and have less jagged edges. So what we do is we call getRay, and then we add the ray color. Ray color is important because this is the function that helps us determine what your ray is intersecting with in our scene. Specifically, we call the w.hit function. That lives in our world class. So in the world class, we have this hit function that takes an array. And what it does is it loops through each object in the scene and it calls their hit functions and sees, is this ray intersecting with that object? The way that the hit function works is every class that inherits from this object class, which is the sphere and the world, all inherit from this class, they have this function hit, which takes in that ray and a couple other things, and it returns a bool, true or false, if that ray intersects the object that we're currently talking about. So for instance, the way that this is implemented in the sphere class is we override the hit function, and we have a bunch of math in here to basically use the quadratic equation to identify whether or not our ray is intersecting this equation of a sphere. But at the end of the day, we either return false or true. So then back in the camera function, the camera class, we add those colors and then we write out the color. Writing the color is super easy because we're using a ppm image, which lets you just write out RGB values for every pixel and then do a new line. So one other important part of the class is this vector3 implementation. So since it's a 3D renderer, we need a way to represent 3D objects and positions. So this vector3 class has basically an X, a Y, and a Z, and then a bunch of helper operations to let us do the math that we need to calculate the bounces of each ray and the intersections of the different objects. So let's run this and see how it looks. So it takes a little bit, not too long, since right now I'm only running it with 50 samples per pixel, so this is pretty quick. So that is finished, and now we can see the final output, which is this image. So we have our main sphere, the ground, and these 2 other spheres, and we can see that the top has a little bit of rim lighting. The bottoms of these are casting shadows, and they would be able to cast light onto each other as well. Now, each of these are lit using diffuse lighting. And basically the way that we handle that is any ray that hits this object, since it has a diffuse material, it can be scattered in any random direction, which causes it to have this really soft, nice look to it. So yeah, that is my implementation of a C++ ray tracer. And a lot of this math is not from me. So what I was able to do during this project is I was able to go through this ray tracing in one weekend tutorial, which was really, really helpful because it starts out and it tells you how ppm images work and vector3 classes and things like that. And then it goes through and explains a lot of the math for the more complex parts, like the sphere intersection with the rays. And this was super, super helpful. A lot of these concepts are deep into linear algebra, and I would have had a hard time understanding them if it wasn't for this really well-written tutorial. Anyway, that is all I have, so thank you for watching.